Okay, so let's quickly come back. We just, on this last video, found the inverse function. And then, as I was, closing it off to remember, I thought, hey, I should read the question. And so the question is actually saying, okay, graph it, which we did, and it said, is f a one-to-one function? And the answer is, yeah, because it passes both the vertical line test and the horizontal line test. Now, at some point in time, like maybe right here, you say, but doesn't it flatten out for a second? And the answer is, no. The answer is no. It gets pretty much flat, but not quite exactly flat. So now here we go. One of the most important things that you will ever do is, at least in this unit, is proving inverses algebraically. And so basically what happens is we're going to use composition of functions, which we have already been practicing, and we're going to put some things together. So we have the inverse composition rule. And so basically what happens is this. We're going to take, and whatever our f function is, we're going to take our f function, and then we're going to plug the inverse into it. So we're going to plug the inverse into the original, and then you have to go both ways. You have to go both ways. Then you're going to take the inverse and plug in the original, and when you do that, you'll get x. So you take the inverse and plug it into the original, and you take the original and plug it into the inverse. I'm not sure I said that right the first time, but do you see what I'm saying? You take each one and plug it into the other one, and you should get x every time. So let's try that. Now, just a quick thought. You don't have to write down all this stuff. You just need to write down the main point, which is you plug the inverse into the original, and then you plug the original into the inverse. You should get x. Okay, so let's try that, and I'm going to color code stuff. So f of x is going to be x to the third. That's going to be my red function. And then cubed root of x minus 1. So just in case, so go back to this one. I think I just said x to the third, but x to the third plus 1. So read what I mean, not necessarily what I say. So x to the third plus 1. And then the inverse is cubed root of x minus 1. Now let's think about it for a second. How do you undo a cubed? You cubed root, great. How do you undo plus? Minus. So I'm guessing that they're probably going to be inverses. And since the question said verify, the answer is they are inverses. We just have to actually prove it. So what am I going to do? I'm going to take my f function and I'm going to plug g into it. And then after I've done that, then over here I'm going to take my g function and I'm going to plug my f into it. Okay, so what does that look like? Well, my original function was x to the third plus 1. Okay, so where the x was, I'm going to put parentheses. I'm going to put the third plus 1. And then I'm going to plug my g into it. So, cubed root of x minus 1. Okay, so now I'm just going to go through and do the math of that, which is actually kind of fun. What happens when you do a third power and a third root? They cancel each other out. So that means this whole thing ends up just being x minus 1. But I have the original plus 1 right there, so x minus 1 plus 1 gives me x. Yay! That is happy fun times. It's exactly what should have happened. Now, over here, I'm going to go backwards. I'm going to start with my g function, which was the cubed root of x minus 1. And I take and I plug my original, my f of x function in there, which was x to the third minus 1. Okay, so I've got a parentheses around that x to the third minus 1, but is anything really happening to it? And where's my mistake? You see it? Yeah, sorry, it's getting late. So, x to the third plus 1 minus 1. That parentheses it's really just showing me where to put the x to the third plus 1. So, glory of glories, joy of joys, those cancel out. So now I have third root of x to the third. Well, what happens? I get x. Woohoo! So yay, heart. That was so much fun. I plugged the two into each other. I got x for both. So yes, algebraically, they are inverses. Just like I thought. So let's do an example right here. Extra example. Let g of x be the inverse of f of x equals negative 2 times the third root of x minus 1 minus 5. Holy cats. Okay, so what am I going to do? I'm going to take that, I'm going to swap the x and the y. This is going to take some thought. So let's make this into a y, and I'm going to swap them. So I get x equals negative 2 cubed root of y minus 1 all minus 5. So I put both the x and the y in red just so we could see them and kind of figure it out. Okay, so I swapped them. Now I've got to solve for y. Okay, so I'm going to go through all my steps that I taught you when you were little. What do I undo first? Undo the minus 5. Plus 5, plus 5. So x plus 5 equals negative 2 times the cubed root of y minus 1. Okay, now I've got to divide by negative 2, divide all of this by negative 2. Okay, I'm just going to leave it like that because otherwise it's just going to be raunchy gross. So now I've got x plus 5 all over negative 2 equals cubed root of y minus 1. Okay, how do I undo cubed root? I cube it. Huh. Okie dokie, Spunky. So now I've got x plus 5 all over 2, all cubed, and then I'm going to plus 1. Yuck. Okay, but like it was multiplying by negative 2, now it's dividing. Oh, I missed a negative right there. Okay, good. It was originally minus 5, now it's plus 5. Makes sense. Was cubed root, now it's cubed. Makes sense. Plus 1. All right, so this is my inverse. Okay, now your job is to plug it in and check out, okay, if I g of x it and I f of g it, do I get 1 out of both of those? So I'm going to pause the recorder. I want you to do the same thing, and then you do it, and we'll come back and check. You take as long as you need, and then I'll be right back here waiting for you. All right, here is all of the work. So I'm going to cover up some of it. You've already seen it kind of, but so here's my g when I plugged the f of x in. So I plugged the red f of x in to the blue g of x. Then I started, do you see in the top, those parentheses aren't really helping us a whole lot. So I can cross out the plus 5 and the minus 5. Then I rewrote it. Now the negative 2's cancel. Then I rewrote it. Now the third root and the third power cancel out. So I've just got x minus 1 plus 1. Woo! Just got x. All right, now we have to try the other one. So this is like just good thought process. This is why I taught you the rules when you were younger and why it was important then when you didn't want to show your work. Why I wanted you to. Okay, so now this one I'm plugging my blue g of x into my red f of x. And so right away, plus 1 minus 1 cancel underneath the square root. Then I rewrite it. Then my cubed root and my third power cancel. Then my negative 2's cancel. Then my plus 5 minus 5 cancel. And awesome, I end up that when I plug in my inverse into my original and my original into my inverse, both of them give me x, which says, yes, I did the work right originally. How much fun is that?